Hi and welcome to this video tutorial on MCP authentication with either Python or TypeScript. In this longer video tutorial, we will understand why MCP authentication is a complex topic, and you will see a implementation that will help you understand this MCP authentication. As a requirement for this video tutorial, you already see them on the screen. You should already be familiar with MCP development. You should have installed VSCode and GitHub Copilot. Of course, it should be also already configured. They are all free tools. You should also have installed Node.js and NPM. And if you want to follow this tutorial for Python, you should already have installed Python and the UV package manager. All the code that will be presented inside this video tutorial will be available for you in the GitHub repository in the description of this video, and also you can check the course outline for different key moments in this tutorial. This being said, let's first see what is MCP authentication. Authorization of web applications is very complex. This is the reason in most cases you would want to use a separate service, an authorization server, in order to authorize calls to your protected MCP server. And the MCP documentation has extensive use on authorization and authentication. I'm looking at one diagram which explains basically how this works. There's also another page, another big page, which explains how MCP authorization works. Let me tell you, it is a very, very complex subject, and this is a very complex read. This is the reason I have made this tutorial, for you to try out a simple example and then move on to more complex applications. How this authorization basically works in MCP? Well, we have right here a client which can make a request to an MCP server but without a token. Of course, in this case, the MCP server will return back a 401 unauthorized response, but it will also contain a header, this www authenticate header, which will contain information about how a request token can be generated and received. And the authorization server will simply generate the token based on the data that we send to it. In the end, we would have a token from the authorization server, and we will be able to use this token inside our MCP requests and receive back positive responses from our MCP server. We will talk in more detail about this problem in the next lecture. I want to point out that if you want to learn, as I said, how authorization works with Model Context Protocol, in my opinion, the best way would be to use a simple, very basic authorization server and then use it in order to secure your MCP server. And there are many options you can choose from for an authorization server. There is, for example, Keycloak, which is used inside the MCP documentation, but is fairly complex. There's ScaleKit, which is a little simpler. There's Stitch, which also works great. But for this tutorial, I will be using a simple, handmade, with a little assistance from GitHub Copilot, a simple Auth server, which will be available as a resource for you. Inside this Auth server, this is basically a simple NPM Express application, which will handle and make public some authorization endpoints. As I said, you will see how this works in the next lecture. But my recommendation would be to use this OAuth, handmade OAuth server, and then move on to established OAuth servers. Let's now move on into the next lecture and understand better how MCP authorization works, and we will see the finished product of this section. Let's now check the sample Oauth server that I have built in order to illustrate how MCP authorization works. You can take this Oauth server from the GitHub page of this course. Inside my GitHub account in the MCP course repo, this is the Oauth server folder. I already put this, checked this out inside my computer, and I have opened this project inside VSCode. The first thing that you have to do is call npm install to install its dependencies. And basically, this is a simple Express application with some hard-coded credentials. So I'm assuming that this is a Oauth server in which we already registered, and the Oauth server returned us a client ID and a client secret. This Oauth server supports multiple endpoints like the authorize endpoint, like the approve endpoint, and like the token generation endpoint. This will generate tokens, and then it will also introspect the endpoint for token introspection, in which will check token validity. Let's see this in action, and to illustrate this, I have prepared a requests.http file. You can make these requests using Postman, using other HTTP tools, but since I'm already inside VS Code, I will illustrate this using this extension called REST client. Because these are simple HTTP requests, there's no reason for me to leave VS Code. You can install this REST client extension, and you can directly invoke these requests directly from VS Code. And the first point, the first type of request needs to be opened inside a web browser. So let's first of all start the Auth server. So I will clear this and I will call npm start. This will start the server, and the first request is in order for us to receive an authentication code. So I will copy this whole URL that goes to the authorize endpoint of this Oauth server with the client ID and with some secret. I will copy this URL, and from inside a browser, I will invoke this and I will see this web page. If I click authorize, in a real world scenario, I should be redirected to the initiator of this web page, but since we directly put this right here, there's no where to go for this, no problem, I will close this. But at this point, if I look back inside the console, I will see that I have an auth code generated. I can copy this auth code. I will copy this and I will put it right here. I have an auth code, and with this auth code, I can make a request to the token endpoint of this application. I will send this request, and what this will do, it will return me back an access token, and I can use this access token to access the data protected and the APIs protected by this Oauth server. For example, I can copy this Oauth token, I can put it right here, and I can check the introspect value, and I can see what exactly is with this token. For example, I can see that this token is true, and it has the client ID and the token type. If, for example, I'm not careful and I change this Oauth token right here, and I send back the request, I will receive an active false. So this introspect endpoint will be used by the client, the MCP Auth client, in order to check the validity of these access tokens. Let's move on into the next lecture and understand the connection between the MCP server and the Oauth server. Before diving into the implementation, let's take a few moments to understand how this MCP authorization works. And understand what exactly we have to write inside our MCP server for it to use an OAuth server. And let's look at the MCP server. Either TypeScript or Python, doesn't really matter. The logic is exactly the same. So what we have to do, we have to somehow have a protected route inside our server, the MCP route, and we will protect it using an authentication middleware, basically a function that will intercept all the requests to this endpoint, and it will check if they have a token. The checking of the token will be done by another function which will live inside an OAuth client, and this client will simply invoke the OAuth server. It will invoke the introspect endpoint of the OAuth server, and basically the OAuth server will tell us if the token is valid or not. But how do we receive the token? Well, this is the point where the MCP server needs to shine. Well, it needs to support at least two new public endpoints, the well-known OAuth protected resource, and for good measure you could support both the simple one and /MCP, and also the well-known OAuth authorization server. And these endpoints will contain data about the OAuth server. It will tell us, hey, if you want to authorize yourself, go to this endpoint inside the OAuth server. So basically this is how things are working. Let's look now, to understand better, let's look now at the finished product by the end of this course. So I'm inside my computer and I will start this OAuth server with npm start. The server is started, and right now we need to authenticate our MCP server to this OAuth server. Remember, this is the finished product. So if I want to do this, I will simply, well, this is already running. I will stop this. I will rename this, and to start fresh, I will simply remove this authentication data from localhost. All right, and let me start fresh. And now inside the terminal, I will first start this server with npm start again. So this server is started and I will start it right here. VSCode will tell me that dynamic client registration is not supported. That's all right. I will simply hard code or pass our client ID and client secret. These are the ones, the client ID and the client secret. Like this. Now I will authenticate this and I will end up inside a web page in which I can authorize. The web page is hosted by the OAuth server. I will click authorize. Then I will simply return back, and now my MCP server is authorized. It is running, and let's try to make the requests that basically the MCP host would make. For example, at this point, if I want to send a request to a protected resource inside the server, like the /MCP, I will get an error and it will tell us, hey, if you want to see what's there, you have to add a bearer token. If I will send again a request, I will send a wrong request, this your token request, which of course is not existing, and I will receive an authentication failed. But if I will take the request generated by our actions, and we can see this request, if I will send this request to the OAuth server, this print tokens is simply a debug endpoint. If I go, I will see now that the OAuth server has stored this token. And basically this is the token we need. If now I will add this token to my requests and invoke this endpoint again, I will receive a OK response. And this will tell us, since I told it as method, hey, give me your tools, give me a list of your tools, I will receive an OK response in which will tell me, hey, you have a list of tools with this name and with this title and with this description. Basically, protected MCP resources at this point. Let's see how this was implemented in the next lectures. In the next lecture, we will see a tip for VSCode cache cleaning, and then you will see the TypeScript implementation and then the Python implementation. Of course, check your lecture accordingly. In this lecture, I want to give you just a fast tip regarding testing OAuth applications with VSCode. VSCode has built in a lot of caching mechanisms for OAuth applications, but this is bad news if you want to develop and then test, because you somehow have to reset the state of this authentication every time you want to make a new check inside your development. You can't just update the code from your server and then restart it, because VS Code will use the cached configuration. For this reason, there's multiple ways in which you can restart VS Code. So this is a state from the future of this application. It will work when VS Code will make these two requests. Let me make them bigger to show you. So the flow is that VS Code makes a post request to /MCP. The MCP server will return back with 401 unauthorized, but then it will make a request to get well-known OAuth protected resource /MCP. And this is the happy case when it will also make a request to OAuth Authorization Server, just as we configured it right here. Let me show it to you. This one. We have a handle for OAuth Authorization Server. So this is the happy case. But sometimes VS Code will enter into a, let's say, bad loop, and you need to somehow reset its authorization status for this server. As I said, there are multiple things that you need to do. First of all, I will stop this server, and there's a very important command. I'm invoking the command palette, and you need to call authentication, remove dynamic authentication providers if you want to check again your implementation. I will select this and I will click OK. I will remove this data. Also, sometimes it will still cache this implementation. This is the reason I will sometimes also rename the server, because we are learning. And if still this is not working, I will simply reload this window. Keep this in mind, keep this information in mind when VS Code won't be able to open a new window to authorize your MCP. Let's first of all create a sample MCP project with TypeScript and Express. So in this lecture we will initialize the project, and in the next lecture we will add the authorization part. I'm inside an almost empty directory. I have this .gitignore and these readme files with some steps. First of all, we need to initialize this as an npm project with npm init -y. Alright, then we need to install our MCP and Express dependencies. We need this @model context protocol SDK and the Express libraries. I will copy this. I will execute this. Then we need to install our development dependencies, and we have more because we are using TypeScript. So we need TypeScript, we need TSX to directly execute TypeScript code, we need some types for Node and for Express, and we need Zod for MCP with TypeScript. Again, let me execute this command and install our dev dependencies. That's great. Let me now create the actual file. So I will create a new folder, the source folder. Inside this folder, I will create the server.ts file. And let's start to populate this. Let me first create a simple MCP project. So we need the MCP server import from MCP. This is the one. Then we simply have to create this server, create a server instance. And I will say const server is a new MCP server. That's great. Let's add a simple tool that will simply say hello to us. So I have called this register tool function on the server, and we are simply adding a hello tool. And now we have to simply convert this MCP server into an HTTP server with the assistance of Express. For this, I will import Express from Express. So upstairs, I will import Express from Express, and we will need a streamable HTTP server transport from MCP. So this is the import streamable HTTP server transport from the MCP library. And now let's set up the server, the Express server. Right here, I will set up an Express server. So this will be a new Express app. We will use JSON. All right. Let me add a simple function that will log out all the requests that this server receives. So I will add a simple logging middleware in which I will simply print out the method and the URL and eventually the body of the requests that this server will receive. And now we should create a simple post MCP endpoint. Let me write the code and then explain it. So this will be the main endpoint of this MCP server, the /MCP. What we have to do right here, we simply have to create a new transport object, this streamable HTTP server transport that we imported upstairs. Then with our MCP server, we are connecting to our newly created transport, and we will simply handle our request. And this way, the MCP endpoint works just fine. In the end, we simply have to start our Express server. Let me again write the code. So I'm calling app listen on the port 8000. And right here, we are simply starting our server. This is our sample Express MCP server. Let's see if this is working. For this, I will add a new entry inside our scripts. I will call this start, and let's simply execute this server.ts file when we call npm start. So I will directly execute this with tsx and then src/server.ts. All right, let's see if this is working. Let me start this with npm start. And the server started. Let's now configure VSCode to directly connect to this server. For this, I will create a new folder, .vscode, and inside this folder, I will create a new file, mcp.json. I'm using GitHub Copilot. For this, you can use maybe other MCP server client if you want, but since I'm already inside VSCode, I'm using GitHub Copilot. So right here, I will add a new servers entry, and I will add right here a new entry. I will call this hello server. Doesn't really matter the name, we are learning, and this will have a simple one URL, and the URL in our case will be the URL of our Express server. This is the one, and let's see if we are able to connect to this server. So if I click start, yes, we are receiving some requests right here inside the server, and if I open GitHub Copilot, right here, I can simply say hello with an MCP tool. Let's see if it will be smart enough to execute our hello MCP tool. Yes, it understood that we want to do this. I will click allow. And yes, we are receiving the nice response, hello from MCP. So this means that our tool is executing. So this is our starting setup for our project. Maybe you have seen this before. And in the next lecture, we will add some authentication to this server. Let's now add authorization to our MCP TypeScript server. First of all, I will start the Oauth server that I showed you before. I'm inside this Oauth Server project, and I will start a terminal right here. I will first of all install its dependencies with npm install, and then I will call npm start. And this will start this server on localhost 4000. So our Oauth server is up and running. Now it's time to add our authentication logic inside our MCP server. For this, I will create some middleware logic. And first of all, I will want to create an authentication middleware. For this, I will create a new folder. I will call this lib, And inside this lib folder, I will create a new file and I will call this auth.ts. This is our authentication middleware. Basically, right here we will create a new middleware function for Express. And if I want to create this for Express, what we need, I will put the types for Express, the request, the response, and the next function. This is Express code, and our function will be like this. So this is our auth middleware function, which will receive a request, a response, and a next argument function. And it will return back a promise of void. Basically, any Express middleware function will look like this. And now let's start with our implementation. First of all, we have to somehow allow the public parts to be executed or to be handled by the server. And I will put the public parts upstairs. So if the server if the client will receive or will request something like well-known or .health or authorize or /token, we will simply allow the execution. And for this, I will first of all put everything inside a try catch block. And if these public parts are requested, we will simply move on with the execution. Let me write this code. So we will allow public access to OAuth discovery, to health, authorization, and token endpoints. So if our public parts include the path inside our request, we will simply invoke the next function, which will allow the server response. Now we simply have to extract the token from the request in order to check it. So I will extract the token from the request. So this will be a authentication header, and I am taking it from the request headers authorization. And let me check for the authorization. And upstairs, I will simply save the very important authentication header. Let me write it and then explain it. So this is the OAuth authentication header. It is simply an object which has the key www authenticate, and the value will simply be this bearer realm, and then we will point out this resource metadata. We will say, hey, if you want to authenticate yourself, you should go to this URL, localhost 8000, so inside this server, to the well-known OAuth protected resource. We will implement this later inside this lecture, but for the moment, this is a very important header that will tell whoever wants to connect to our data that they should authenticate first at this address right here. This is like the most important point inside this lecture. So in case we don't have a header, we will simply return a response that will tell, hey, so if we don't have an authentication header or it doesn't start with bearer, we will simply return us back a 401 status, and we will add this header, www header, that will tell the client, hey, go to that address if you want to authenticate yourself. Let's now extract the token. So I will simply extract the token. I will extract the token right here, and this will be our token. Then we will simply have to validate this token using a library. We will implement this library after we are done with this authentication server. So at this point, we should somehow right here check the token. I will first of all hard code this because I want to finish with this implementation. So I'll say right here const is valid. I will make this true, but this should be a method from a client that we will write after we are done with this authentication middleware. All right, so we have this const is valid true. And now I can say, if again you are passing a token which is not valid, I will simply respond with a 401 status response. We will add this authentication header and we will say, hey, your token is invalid. And I will simply write here outside this, I will return the next function. So we want to continue executing the code. And if something is wrong at the middleware level, again, I will print out the error and I will simply return back an error message. So this is our authentication middleware. We can simply add this function to our Express server and basically we are almost or half done. We still need to implement our OAuth client, but inside this server, let me import the function that we just wrote. So right here, I will say right here auth imports, and I will import this function. Inside the lib, we have the auth, and we have this auth middleware. I will simply add this auth middleware inside our Express application. So right here, I will call app. We want to use this auth middleware. We can simply pass a reference to this function, so we don't have to execute it like this. This would be wrong. We simply will call this auth middleware. I will create another middleware function, but this time for course. So I will create a new file and I will call this course.ts, because at some point we will return an response that will be executed inside a browser. And if we are talking server and browser, we need a course configuration, otherwise things won't work at all. Let me write this function and then explain it. So again, we have this type imports from Express, the request, the response, and the next function. This is Express code. We are receiving a request, a response, and the next function. And we simply need to add these headers to our response. We will add this header, access control, allow origin, and I will allow all origins. I will allow these methods and these headers. And if the request method is option, we will simply set the status to 104. Let me add this course middleware to our server. Again, this is very important. At some point, we will make requests to this server from inside a web browser. This is the reason we need this course middleware. Otherwise, it won't work and course issues are very nasty. Import again. Inside this lib, we have this course and I have this course middleware. Let me also use this. So at this point, we have the authentication middleware. We will also need a authentication client that will invoke our Auth server and check the tokens. For this, I will create a new file right here, and I will call this cool Oauth client.ts. Let me write the server configuration. So we will want to connect to this address if we want to check tokens. So the job of this cool Oauth client would be to check the tokens. I will use this hard-coded data that I'm also supporting inside this server. I have hard-coded this client ID and client secret because we want to learn right here. So we will use these credentials in order to authenticate right here, to authenticate our calls. I will create a simple interface, to have some strong types. And this OAuth client will have one simple method, which is called check token. This will receive a token and it will send back a true or a false response if the token is valid or not. And in order to do this, we will simply make a fetch request. Let me write this request and then explain it. So we will make a fetch request to our base URL /introspect, because inside the Oauth server, this is the endpoint that will be used in order to check tokens. All right, and right here we will pass our request body. We will pass the token and then the client ID and the client secret. And then we simply have to somehow handle these responses. Let me format this a little. And after we have a response, let's handle the responses based on their values. Or so if we have a response which is not okay, we will simply throw a new error because this failed. If we have a response which is okay, we will simply extract the data from this response slash or response JSON. And if the client ID is different, then we will add an error because the client ID is mismatched. If the response is not active, we will say token is not active. And if all these errors not happened, at this point we can finally return true to inside this function. Now we can use this function inside our authentication middleware. So I will import this. From this cool OAuth client, I will import this check token function. And right here, when we are checking the token, I will say right here, await our check token, and I will pass our token. All right, we also at this point have this client, and in the end, all we have to do is to implement the 2 new endpoints that our server should support. One endpoint is this endpoint that we specify in the authenticate header, this well-known auth protected resource endpoint. So inside the server, I will create a new endpoint. Right here, let me make some room right here because this will be some code. Let me write the endpoint. So this will be a GET request to the / well-known OAuth protected resource / MCP. This is very important. Use this / MCP if you want things to work. And then we will simply return back or add this JSON to the response. We will specify the authorization server, the Oauth server that we are using, the server that we started, this one right here as the authorize endpoint. I will specify the bearer method supported, the resource, and this resource is basically the URL of our own server, this localhost 8000 MCP, and the scopes supported if you want to implement fine-grained access to your tokens. We should also support another endpoint. Let me write it down. We should support, if we want to use Oauth Server inside our MCP application, we should also support this Oauth Authorization Server endpoint. Again, and this contains almost the same data, but this one also supports this authorization endpoint, the token endpoint, and the registration endpoint. All right, let me save this, and I guess with this we are almost done. I guess at this point I simply have to test this implementation. So inside the MCP JSON, I will stop this request, this server right here. VSCode has a lot of caching, and in order to remove this caching, I will add it a different name, and also I will invoke a new command from the command palette. You can invoke this while you are developing Oauth Server, because I want to remove everything that VSCode has cached. And for this I will call Authentication, remove dynamic authentication providers. If you don't call this, then VSCode will use your previously OAuth data, and even if your server should work, it will use the data from previous calls and your server won't work. It took me a day to figure this out, so I will call this. At this point I don't have anything, but I want to make sure, and now at this point I'm able to start this server. I'm receiving an error. What's the problem? Oh yes, I haven't started the server. All right, one more time. Yes, it will tell me that this VS Code will tell me that dynamic client registration is not supported. I will simply click copy URIs and proceed. And at this point, I have to provide an OAuth client ID. And this is the one that I have hard-coded right here. Unfortunately, I can't see it, but it was my MCP client. This is the one, and the client secret is super secret key 12345. This is the one right here. I will click on enter. I will click allow. And what this will do, it will open now a window inside my browser. I will click authorize. And now my MCP client is authorized. I'm able to invoke it. Let me invoke it. Let me clear this context and let me ask again GitHub Copilot. Say hello with an MCP tool. It will execute this MCP tool and I will receive back a response from my MCP tool, but this time it was over a secured HTTP MCP application. Let's now initialize a new MCP project with Python, but this project will be a little more complex because we will need to handle more complex requests, HTTP requests, and that is the reason I will also use a fast API library for Python. This is the reason the project initialization, it will be a little more complex, but nothing too complicated in my opinion. First of all, we need to call init inside a new empty directory. Created this project. I will call add and we need the MCP CLI dependency. So I'll call MCP CLI dependency. This is the one. All right, very nice. And I will also call add fast API. We need a more complex solution to handle more complex requests, HTTP requests to this project. So I will also use fast API. I will also create a .gitignore file. In which I will add the PyCache folder and also the .vnv folder like this. So this is our project initialization. Let's now create a simple server Py function and project in which we will create our MCP application. Let me rename this to server.py. This is our file. And first of all, we need the imports for MCP. So if we want to use this, let me delete everything. If we want to this. So in server.py, we first need the import for fast MCP. This is the one. And we need to create a new MCP application. So lower down the line, this will be MCP. And this will be a fast MCP application. Let me give it a name. Hello MCP. It will be a dump hello application. What we have to do is to serve this MCP application over HTTP using fast API. And let me first of all write the imports. So from async context manager, from context lib, I will import async context manager. From fast API, I will import fast API, and I will also use uvcorn. This is required for fast API. Let me also write the code for fast API. So we need to create a lifespan object for this fast API application, and then I can create a new fast API application with this lifespan. And also at the end of this implementation, when we will start our fast API application, let me write what we want. So inside our fast API application, we will call the mount method and we will mount the MCP streamable HTTP application. And this will be the main entry point for the MCP server. It will run on localhost port 8000. Let's see if this is working. And in order to check if this is working, I will simply create a new dump resource. And for this, I will simply create a new tool inside our MCP. I will create a new MCP tool. I will call this hello name, and this will say hello to the provided name. This is basically our starting point of the authentication project. Let's see if this is working. To check this, I will simply start this inside the terminal right here with uv run and then our server.py. And yes, the server started. And to check it, I will create a VSCode MCP file inside a vs.vscode folder. I will create a new file and I will call this mcp.json. Right here, I will add a new servers entry. This will be a hello server. The name will be hello MCP, like this, doesn't really matter. This will simply have a URL argument, and the URL will simply be the URL of our FastAPI application. Like this. Let me save this, and I can start this. It has an error. Let me check it. Oh yes, it's localhost 8000/MCP. Like this. Let me restart it. And yes, now it's running. Let me check it inside GitHub Copilot. Right here, I can ask, say hello with MCP. Let's see if it will know to invoke our hello function. And yes, I will allow this. And our MCP function is executed, but this currently is not secured. Let's secure it in the next lecture. It will be interesting. Let's now add authentication to our sample MCP project with Python. Before starting to do this, we have to start our Oauth server. So I'm inside the Oauth server project. You can take it from the resources of this lecture or from GitHub. Right here, I will start a terminal. First of all, I need to install its dependencies with npm install. And then I have to start it with npm start. And now our Oauth server is running on this address. Now let's start the implementation of our authorization inside our MCP server with Python. And what we need, first of all, we need some middleware for authorization. For this, I will create a new folder. I will call this lib. And right here, I will create a new file. I will call this auth.py. And this file will contain our authorization middleware. Let me make some room because there will be some code right here. So from FastAPI, I will import the request object, and then I will simply write the auth middleware function. So this is basically our function. It will receive a request of type request and then the call next function. And let's start to implement this function. I will wrap everything inside a try block. And first of all, we have to somehow allow calls to the public parts of our application. So the public parts of our application, let me put them right here, are these ones. So when we will receive requests for well-known or for the health endpoint, for the authorized or for the token, we will simply allow these requests inside our server. So if any path right here inside our request is inside these public paths, we will simply return and invoke this call next function. Then we have to extract the token from the request. So I will extract the token from the request. This should be fairly easy to do. All we have to do is to get the authorization header from the request. And now comes the important part. If something is wrong inside the authorization of this request, we should return back a response containing the authorization required header. Let me write it upstairs because we will use it multiple times. This is the header I'm talking about that we should return. Its value, its key is www authenticate, and then the value is this bearer real OAuth. What's very important is this resource metadata endpoint. And this will tell the application, hey, you are not authorized, but if you want to authorize your requests, you should go to this address. And later inside this lecture, we will also implement this well-known OAuth protected resource endpoint right here. But moving down in this implementation, so if we have this authorization header, if something is wrong with this authorization header, I will simply, so if we don't have this authorization header, or this authorization doesn't start with bearer, we will return a new response. This response also should come from FastAPI. So let me import this FastAPI code, this response, in which I will tell it, hey, you are missing your bearer token. And very important, as headers, we should also add this www header for authentication. Then I will extract the bearer token from the authorization header, and this is the one. This is our token. Again, at some point in the next file that we will implement some logic that will check the token. Currently, I will simply call isValid, and I will make this true. I will hardcode this to true, but in the next file that we will implement a way to check this token. Well, if is not valid, so if there's a problem with this token, we can simply return back a response that will tell, hey, your token is not valid, but if you want to get valid tokens, you should first use this header to authenticate yourself. And if this error is not or this case is not handled, this means that everything is working as it should. Then we will simply, at this point and only at this point, we will return the await call next function like this. So at this point, everything should be all right, and we will allow the execution of the request. I will also handle the error. So if there's some exception in this workflow, I will simply say authentication failed, and again, I will return back a header containing our authentication request header. This is our authentication middleware. Now we should also implement a way to check for the validity of the provided token. For this, I will put this inside a new file, to have things organized inside our code. And I will call this cool OAuth client.py. And this structure should mimic the way you should use other established OAuth providers. So I will hardcode the server configuration. We will make some requests to this Oauth server. And let's say we are already registered to this server, and this server gave us the client ID and the client secret. These are just hard-coded data that this server already accepts. Because we are learning, I don't want to make this more complicated than it already is. And I will create this function called check token. This receives the token and returns back an object. Let me write the function implementation. So this is the function implementation. So we are making a post request into the URL of our Oauth server into the introspect endpoint, because this introspect endpoint has the mission to check for tokens validity. If everything is all right, then we should return simply true. This should return a bool, not a dict. All right, so this is our check token function. What we can do, let me also add these requests to this project. Let me stop this and call uv add requests. All right, don't forget to add this library. And now we can use this cool OAuth client inside our authentication logic. So let me first import it from right here. So from cool OAuth client, I will import this check token function. And right here where we are checking for the isValid token, I will simply say check token our token. Like this. And now all we have to do is to, inside our MCP server, to implement this MCP endpoint. And we will also add some middleware for CORS. So inside the server, the MCP server right here, let's now switch our efforts inside the MCP server. We should add this authentication middleware. So from our lib authentication, I will import this auth middleware. And right here, when we have a fast API application, I will call app. You will add an HTTP middleware. And right here, we will add this auth middleware right here. I will add another middleware for CORS handling. So upstairs, where we have the fast API imports, I will add a new import for middleware, for the CORS middleware. And the reason I'm adding CORS middleware to our fast API application is that at some point this MCP server will receive requests from inside a web browser. And if your server receives requests from inside a web browser, it's very important to handle the CORS issue. Otherwise, you will have some very nasty CORS issues. I will add this code right here. This is the CORS middleware handling, in which we will simply allow all the origins and these methods. Yes, of course, in a production environment, you should specify the actual origin where this request will come from. All right, but now it's time to add our very important new endpoints inside our application. So let me make some room right here, and we first need to handle this well-known OAuth protected resource. Let me write this code right here and then explain it. So this is our handling of our well-known OAuth protected resource /MCP. Very important, don't forget about this, otherwise you will have some nasty errors. And what I'm returning right here, we are returning this authorization server. So we are telling whoever requests this information, hey, if you want to authorize yourself, go to these endpoints, this endpoint right here. I will specify this resource, the localhost 8000 MCP. This is the address that this server, this MCP server will live on. And we will also have to handle another endpoint. Let me write it downstairs. This other endpoint is for well-known OAuth authorization server. So we have these two endpoints, OAuth protected resource MCP, but we also have to handle this OAuth authorization server, which again will have a authorization endpoints and a token endpoint, and basically other stuff right here. And basically our application should be good to go. Let's see if it is working. So for this, I will first of all check if the server, the OAuth server, is running. Yes, it is running. I will also go now to the MCP JSON right here. Since VSCode has a lot of caching inside in the background, I will simply rename this. And very important, I will call in the command palette, the VSCode command palette, I will call authentication remove dynamic authentication providers. I will select this one. I have it already from the TypeScript implementation of this code. If you don't see anything right here, then there's okay. But every time you make a change inside your OAuth server, be sure to check this command, otherwise VSCode will use some cache data and you won't know why your new implementation is not working. It took me a day to figure this out. I will remove this data. And now I will start this. First of all, I will go to the terminal. Let me clear the terminal and run uv run our server.py. All right, I have a small error. Let me check it. Well, I had a typo right here. I had the dot right here, but this is the way to import this. And now I can start the server again, uv run and our server.py. The server is started, and now I will go to MCP JSON. I will start this MCP server. Now I will be prompted for a dynamic client registration. Well, it will be a small warning message from VSCode that dynamic client registration is not supported because we didn't configure this /register endpoint, but that's okay. We will do it the manual way. We will need manually to add our credentials, and we can see them inside the cool OAuth file. We have the client ID, which we already have. We assume that we already registered ourselves inside this Oauth server, and then I will copy the client secret. All right. And now VS Code will tell me that the MCP server wants to authenticate to localhost. I will click allow. And what this will do, it will open a new browser, and inside the browser, it will open localhost 4000/authorize with my client ID and some encoded challenge. Well, I have the option right here to click authorize. So I will click authorize, and now back inside my server, I can see that it is running. So at this point I'm able to invoke the secured MCP server. If I go to GitHub Copilot, I can ask it right here, I'm Alex, say hello to me with MCP. And let's see what we get. I will allow this, and I will receive back a response from the secured MCP server. This means that this finally worked.